Our last speaker in this session is Edwin Constable. Ed is a professor emeritus from the chemistry department of the University of Basel, and he's still very active in many different roles. Amongst others, he's the president of the Swiss Center for Scientific Integrity. He's on the board of trustees of the Royal Society of Chemistry, and he's the vice president of UPAC Division 8. And after we've now heard a lot about the women and a little bit about their chemistry already, he will dive more deeply into the chemical research questions that some of these pioneer women worked on. Excellent. The floor is yours. Thanks.
Thank you for the introduction and also for the opportunity to be here to celebrate these remarkable women. I think I've chosen the title Agents of Change because I think that these pioneers, in particular in the sciences, changed the way in which university education developed in the 20th century to the gender parity that we see in many disciplines today. You will also notice that, like Caspar, I had a problem trying to find the correct way to say in elegant English female doctoral candidates. So I'm afraid I've used doctorandin here. And as Leo told me I have 840 seconds to speak, I decided to choose 3 of these early female chemists to look a little bit at their chemical contributions and also the lasting, if there was a lasting, effect of those contributions towards the development of chemistry. So I chose 1 from organic chemistry, 1 from physical chemistry, and 1 from inorganic chemistry. And so, like my colleagues, I started with Lydia Sesemann, and she collected all of the firsts, if you like. She was the first female chemistry doctorate in the world, by definition then the first female chemistry doctorate in Zurich. She was also the first female Finnish doctorate. And I think that this is a theme that's going to come through multiple times. The vision that the University of Zurich had in its internationalization, even at this early stage, these early achieving women came from around the world. She was born in Viborg, I don't need to say any more about that, and she studied natural sciences in Zurich, 1869 to 1874. And I just want to bring a little bit of attention to those dates, because the time between matriculation and the doctorate was actually quite short in almost all of these early doctoral candidates. And I think that it shows the spirit of what we now think of as the third cycle in education, that the doctorate was just the final part of the education, in this case, within chemistry. Her dissertation was under the supervision of Victor Merz and Wilhelm Weigt, über die Benzyl-Essigsäure und eine neue Synthese der Homotolylsäure. And as mentioned, she was one of the students affected by the decree from the Tsar that Russian students had to leave Zurich. She didn't. She completed her dissertation, but the doctorate was awarded in absentia. So what did she do? And here, when I looked at her thesis, I actually thought, this looks familiar to me. And when I thought back, this was actually the very, very first piece of independent research that I ever did between school and going to university. But I wanted to make the compound, which hopefully has got a nice red circle around it, this compound here. And I'd just like to draw your attention to this synthesis that she did. It shows not only the courage of these early chemists and early female chemists. This is a reaction I would hesitate to do today. She started with the sodium enolate of ethyl acetate, which she made, now I think this was before Schutzgas, before you worked in an inert atmosphere, by heating ethyl acetate with sodium. She then took this pyrophoric mixture and dropped a very reactive organic compound on it, benzyl chloride. Not content with that, she then heated it to over 200 degrees. Well, she got a mixture of the mono and dibenzylated compounds. I did a very similar reaction in solution many, many years later. And the first thing you notice when you do this reaction is the entire laboratory fills with a smell of flowers. It's actually the smell of hyacinths. And it is actually overpowering. It's like going into a room in which the perfume of all of your aged aunts and your grandmothers are collected together, and you smell of this for months afterwards. However, it's still used as a flavouring and as fragrance agent today. Was this a world-shattering discovery? Well, the Chemische Berichte paper has only been cited 5 times in the last 100 and whatever years. Her dissertation was presented in the quarterly report of the Natural History Society in Zurich. But what is more interesting is that we find in Kekule's Lehrbuch that her work is referenced twice in it. And I wondered a little bit about this. I mean, how had he seen this? And of course, he had a fairly comprehensive overview of the chemical literature. But actually, if we go back to this Chemische Berichte article, guess who wrote the next article in that volume of Chemische Berichte? August Kekule. So maybe that's how he actually identified this work. And that is pretty much it for chemistry, as far as she's concerned. She certainly never used her chemistry doctorate in a professional capacity. The Leipzig connection was mentioned in Chemische Berichte, but I also couldn't find any evidence that she was actually practicing as a chemist in Leipzig. In 1877, the research theme was discontinued, and she spent the rest of her life in either Munich or Lausanne, or traveling between the two, as far as I can see. But there is no evidence that she ever had any further professional contact with chemistry. Just to show you, this was the mood of the time. Just 6 months later, we find that Julia Lemontova received also a PhD in organic chemistry. This was in Göttingen, and I think was the first female PhD in chemistry in Germany. And again, a very austere-looking late 19th century German lady. So, organic chemistry, and we now move to physical chemistry. And I sympathize greatly with Gisela in that it is exceptionally difficult to find anything about Marie Stahlmann. She performed her work at the Polytechnicum, and the doctorate was then awarded by the University of Zurich. You'll notice I have no photograph of Marie Stahlmann. There doesn't appear to be a photograph of her existing. She, I think, was the first female chemistry doctoral candidate from the Polytechnic, but there may have been one earlier. She studied under Weber, who was Einstein's original doctoral thesis advisor. I say his original advisor because Einstein changed thesis advisor because he said that Weber's lectures and outlook on science were a view from 50 years in the past, which may be reflected in the theme, investigations of the specific heat of water. So what did she do in her remarkably short doctoral thesis? She determined the specific heat of water at various. I'll say a little bit more about how she did this, not about why she did it, but how she did it. The work appears never to have been published in a standard reviewed publication, but the thesis abstract was published. And again, although there wasn't a primary publication, the work is referenced by name in the section on the properties of water. So her work had some impact. And what she did was she mixed known amounts of water and of other substances. In this case, they were turnings of copper within a calorimeter. Her thesis is actually a rather good description of the technical process of doing this. So she describes, first of all, how you calibrate a thermometer. Something you don't even think about today, but she had to calibrate her own thermometers, which were accurate to, she said, by eye, 1/100th of a degree. So they were calibrated to 1/10th of a degree, and she could read it to a further 10 graduations there. She also had to determine the specific heat of the copper she was using, because she was looking at the heat transfer between the water and the copper. And she spotted quite correctly that the type of copper you use actually determines the specific heat of the copper, and she had to measure that as well. What she did do was show that the specific heat of water increases slightly with temperature, that it was not constant, but it rises roughly in proportion with the temperature. Observations which have impact today, from everything to design of your kettle in your kitchen through to heat exchange within nuclear reactors. But she's not known for that work. And then afterwards, I'm afraid, I can't find when or if she died. I can't find when or if she married, which of course would help, because then we can find another name. All I can say is that she wasn't one of the victims of the pogrom in Kishinev in 1903, which was where she came from. So that's it for Marie. I'm going to come quickly to the first inorganic chemistry doctorate. She was also the first English doctorate in chemistry at the University of Zurich. As mentioned, she studied under Alfred Werner. This is her in a laboratory. I hesitate to say it's her in the laboratory here, because I have a suspicion this is actually in the Sanderson lab that she went to in the United Kingdom afterwards. She worked on cobalt complexes, in particular ethylene-diamine, sorry, I should put a UPAC hat on, 1,2-ethane 1,2-diamine complexes of cobalt, and she prepared the first series of compounds with 2 ethylene-diamine ligands and 2 other ligands, either bromines or chlorines or nitrites or nitro groups. Her doctorate was awarded in 1901, and here we can begin to see some impact, I think, that has gone through the generations. As mentioned before, she worked in the catechumen. Her thesis is a rather comprehensive study of the preparation and characterization of these cobalt complexes. It's the classical method of characterization. Smell, color, taste. This was published in Berichte. This seems to be her only publication. But what she did was prepare this compound, 2 ethylene, and I've chosen the nitrogen compound. So this is 2 NO2 groups bonded through nitrogen. This compound is one of the first examples of an inorganic compound which doesn't contain what at the time would have been called an asymmetric carbon atom, but where there is no stereogenic center within the carbon backbone. But nevertheless, I've tried to show that the 2 mirror images are not superimposable. So this compound, in principle, could be resolved into 2 enantiomers. I wish I could say that Edith Humphrey did resolve this compound. She didn't. That was left for another 10 years till Victor King. But this was the beginning of inorganic stereochemistry as we know it. I would also argue that it's probably the beginning of metallosupramolecular chemistry, because the idea of using a metal to control the shape and the properties and the reactivity of an organic compound can all be traced back towards this compound. What happened to her after her doctorate? She had a little flirtation with Leipzig. She clearly didn't want to distract the students. She returned to England, and then she worked for the rest of her career in chemistry, the first of these to remain in chemistry. She worked for Arthur Sanderson and Sons, now Sandersons. Some of the reports say she was actually in charge of the research laboratory there, as I think they probably only had 2 or 3 chemists. That is quite likely. Almost certainly she was working primarily with dyestuffs and with colors, because Sandersons made paints and wallpaper. You may be today familiar with their products because they inherited the patterns from William Morris & Co., the classical arts and crafts manufacturer of the late 19th century. And even today, if you buy the Morris pattern wallpaper or the fabrics, they're made by Sanderson. As mentioned, she became a fellow of the Royal Society of Chemistry in 1933, and there appear to be no publications from the remainder of her lifelong career at Sanderson. She gave an interview to the British journal New Scientist on her 100th birthday. She, as Gisela mentioned, complains about the cost of living in Zurich. Some things don't change. She also describes being called to meet Mendeleev at that time, which I don't know if that was a confusion on her part, because I can find absolutely no evidence that Mendeleev was in Zurich at any time when she was present here. The only time I can find he was actually in Zurich was in 1880. But I do know there was a correspondence with Werner, so I suppose it is possible. So, 3 ladies, 3 topics, and I did manage to find in the Royal Society of Chemistry the actual crystals that were presented on the occasion of the 150th anniversary of the Royal Society of Chemistry, and these were presented by the Swiss Chemical Society. So I've just put this photograph in to prove that they are still there, they've not been lost, and that these are actually the crystals of the nitro compound that Edith prepared. So, to finish, the internationality of these first students is remarkable. They came from all over the world, because it was the only place they could study for a doctorate, but nevertheless, Zurich welcomed them with reasonably open arms. These women were struggling against an all-male laboratory, and yet they came through. Depressing is the fact that very few of them actually continued with a career in chemistry. Lloyd was one, Humphrey was another, but many of them we just don't know enough about, but they certainly didn't seem to go into the chemical constellation. And I'm leaving one question here, which actually goes back to the introductory remarks. Where were all of the Swiss women studying science, not medicine? In those first cohorts of female students in Zurich, there were medical students, but there seemed to be a social barrier towards women studying science at that point. And just to make a closing remark, I did find one documented engagement from Lydia Sesemann. Together with Vöchtlin and other colleagues, they wrote to the rector of the University of Zurich, requesting improvements in the conditions for early career female workers at that time. But that was when she was still probably an undergraduate or just starting her doctoral studies. That was an overview in 3 different subjects showing the sorts of chemistry that was being performed by these very early pioneers, but also showing that even after getting the doctorate, life was not easy. You couldn't continue your career in science, perhaps in the way that they had imagined when they commenced their doctorates. Thank you for listening to me.